Welcome. In this podcast, we're going to be performing similarity transformations. All right, so similarity transformations, as we saw in the last podcast, involves a dilation plus another transformation. All right, when we're completing these, there we go. First, do the dilation. Since you're figuring out the dilation, let's make it about the origin, because that will be easier. Right? Unless there's some real reason not to have it about the origin, we're going to go with origin. Right? And you have to figure out scale factor. So remember that K, which is your scale factor, is just the image length over the pre-image. And remember, you want to look for vertical and horizontal lines because they're very easy to figure out the length of. Once you've done the dilation, then you can figure out other transformations. Right? And which transformation it'll be will depend upon whether your pre-image and image are facing the same direction, are they turned, are they reflections, etc. All right, so let's look at our first one. All right, so let's find the scale factor first. All right, and we want to choose a good length. Right? We actually have lots of choices because we got lots of vertical and horizontal lines. Right? We just want to make sure that it goes from an integer value to an integer value. And I think a perfect one to use might be E prime D prime, or E double prime D double prime. The double prime, by the way, is because there was a dilation and a transformation, and another transformation in isometry. I think E double prime, D double prime, and ED would be good ones, right? Because their length is really easy to figure out. Right? So E double prime, D double prime, that's 1, 2, 3, 4, 5, 6. Nice, easy number there. And ED is 2. Right? So our scale factor, I'll put it over here. K is the scale factor, or you can put SF if you prefer. Right? We're going to use E double prime, D double prime over ED. And so that's going to be our image is 6, and the pre-image is 2, which means our scale factor is 3. Right? So that's the first part. Right? Dilate about, so that's our first transformation, dilate about the origin with a scale factor of 3. Right? So then we got to figure out the other part. Right? So to figure out the other part, let's do that. Let's dilate. Right? So we're going to write down the points for A, B, C, D, and E, and then dilate. Right? So it's not necessarily going to end up in the same location as the image, but it's going to be the same size, and then we can figure out what else to do. Right? So we're going to multiply our coordinates, which is A, B, C, D, and E, right, by our scale factor. And then we'll have to squeeze those in somewhere. Let's see, so A is at 0, 2. I'm going to make this just a little bit smaller. Space is at a real premium here. There we go. And B is at 2, 2. And C is at 2, 0. D is at 2, negative 2. And E is at 0, negative 2. Nice, easy numbers to deal with. All right, and so when we multiply by 3, we'll have A prime, B prime, C prime, D prime, E prime. All right, so just multiplying by 3. So that's going to be 0, 6, and 6, 6, and 6, 0, and you know, I'm thinking I should have moved this on the other side, but because I'm right on 6, but I just move it over slightly. So a little hint, don't put this on 6, because you're going to have trouble fitting everything in. 6, negative 6, and 0, -6. There we go. Right? And I wonder if I could make it smaller. For some reason my pen is writing a little large today. I had some issues with the sizing of things earlier, and I had to change the display and all kinds of stuff. And just kind of moving everyone over just slightly, except one little piece doesn't want to move. There we go. All right, now I can kind of squeeze our figure in there. All right, so we're going to graph our first image. All right, and so that's going to be at 0, 6. So right there. And 6, 6. So over right here in the middle of my writing. Oops, no, 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 don't you move. Don't you move. Don't even think about moving. Trying to remember where this was. This was on, that point I think was 0, 6. I just grabbed one point. There. But you can move. There we go. All right, so 6, 6. Now we can squeeze that point in. And 6, 0. And 6, -6, which is going to be, well, it's just going to have to deal with being right on top of the O there. And 0, -6 right there. All right, so here is our first image. The big giant E here. All right, and so this is A prime, and this one was B prime. And what else we got there? We got C prime and E prime, and in the middle of my numbers is D prime. All right, so now we need to translate, we need to transform our first image to our second image. Well, if you look at it, they're facing the exact same direction. It's just one nice little big E next to that nice big E. How far do we have to move? All right, so A prime is sitting at 0, 6, and a double prime is sitting at, that point happens to be -7, -7, 6. All right, so I don't think it's too hard to figure out what you'd have to add to 0, 6 to get to -7, 6. All right, we're just moving 7 to the right. Let's write this in coordinate notation, all right? And I'll write down what it is next to it. So we want to translate. We just want, did I say 7 to the right, by the way? If I said 7 to the right, that's 7 to the left. 7 to the left. All right, so we want to go in the negative direction. So that's going to be x -7, but the y coordinate's not going to change at all. Right? So that's how we'd write it in coordinate notation. And you know, in the interest of space, I think we've done coordinate notation for long enough that you know what that is, right? And so I'm not going to rewrite that. So we're going to dilate about the scale origin scale factor of 3. And actually, if you want to know a shorter way we can write that, because it's a little cramped up here, there's a shorter way we can write that. That might be a good thing to do. If we are dilating around the origin, we can use coordinate rule, and it's only for dilating around the origin, but we've all decided that we're going to be dilating around the origin here. All right, so we can use D for dilation, xy maps to, and what did we multiply x and y by? 3x, 3y. All right? If we don't write anything in here, we only use this coordinate notation when it's understood as the origin, right? So we don't have to write origin. But if we're not dilating around the origin, we can't use the coordinate notation. Let's use the coordinate notation because that takes up a lot less space. Should have done that from the beginning. All right? And then we're going to translate, and we translate 7 to the left, so it's x -7, but we didn't translate it all up or down. There we go. We'll use coordinate notation, and that will take us less space. All right. Now that we've gone through a little slower on number 1, I bet you we can go a little faster on number 2. All right. So first of all, we want to get it to be the same size, right? Not the same size. So we want to figure out our scale factor, right? And remember our scale factor, I think a good place to write might be over down here. Our scale factor is the image over the pre-image. Again, have lots of good choices. How about A double prime, B double prime? The only thing you don't want to use is you don't want to use anything where you had to estimate the coordinates, and you don't want to use anything where it's not vertical or horizontal. Find something vertical and horizontal to use. Right? So A double prime, B double prime, well, that's just one, big whopping old one there. And AB is 2. Well, there we go. There's our scale factor, 1/2. No simplifying needed. All right, so we're going to dilate, and we've got A, B, C, D, E again. And we're going to multiply this time by 1/2. Okay. So we've got our coordinates are for A, B, C, D, E. We make sure we're using the pre-image here. So A is at -6, -2. And B is at -4, -2. And C is at -2, -4. And D is at -2, -6. Isn't it nice these are all even numbers? It's going to be really easy to multiply by half. Just divide them by 2. And then E is located at -6, -6. All right, so when we multiply by half, our first image, our dilation, is going to be located at, divide these by 2, -3, 1, -2, -1, -1, -2. Oops, where's my negative there? These are all negative. -1, -2, -1, -3, and -3, -3. So all we had to do, multiply by half is the same as dividing by 2. And everybody's negative because that's sitting in the third quadrant. All right, so now let's graph our dilation. All right, so -3, -1 would be right here. And -2, -1 is right here. And I don't know we're going to write all the, I don't think we're going to label it. We should always label, but I think it might be a little crowded here. It's not a very big figure. -1, -2, so that's right here. -1, -3, right here. And -3, -3, which is right here. So here is our little figure. All right, so not facing the same directions, not a translation. All right? But if you notice, they are mirror images of one another. So, and they're mirror images over our line of reflection here is the x-axis. So this is going to be really easy to write our rule here. So you see how much easier it is if you do the dilation first and then do the other transformation. If you try to do it the other way, most times it's going to be very difficult to get it to map. And then when it dilates, then you got to try to figure out how do I get it to be right on the same spot. Don't worry about the dilation. Just dilate around the origin, get it the same size, and then the rest of it's easier. All right, so we have a dilation here, an xy mapped to, all right, so our scale factor was 1/2, so we're just going to have 1/2 x and 1/2 y. Easy peasy, lemon squeezy cheesy. The only thing I need is more space. I think I gave you guys a reasonable amount of space. You can write smaller than I can. I'm kind of limited by what my pens can do. And now let's continue to use coordinate notation. All right. So we have a reflection here, and xy goes to. All right. So if we want to reflect over the x-axis, the x's aren't going to change. The y's are just going to be the opposite, right? The y's went from negative to positive. So we can write that as x negative y. And that's understood to be a reflection over the x-axis. Right? And I can just put that in there. X-axis. All right? Or y equals 0. All right? Let's try the next one. All right? So first of all, let's do the dilation. All right? And so it's got lots of great points to choose. How about A prime, D prime, and AD, right? So our scale factor, A double prime, D double prime, that's 4. And our pre-image, so the image over pre-image, AD, that's 2. So 4 divided by 2, that's 2. That's our scale factor, right? So we know what our scale factor is for our dilation. Now we just need the second part of it, which is the whatever else we have to do. So let's figure out where it's supposed to go. And I guess I'll write over here. Right, so 2 is our scale factor, and we're just going to multiply our points, A, B, C, D. We'll have 4 this time. A is at, make sure I look at the pre-image, A is at 1, -1. And B is at 3, -1. And C is at 2, -3. Oops. A, B, C. And then D is at 1, -3. Now we're just going to multiply those by 2. All right, so now A prime, B prime, C prime, D prime. All right, so that's going to be now at 1, -2, 2, -2. And 6, -2. And another 6, oops. Since when is 2 times 2? Forgot what I was multiplying by. I'm thinking, I guess, of problem number 1 where scale factor was 3. 6, -2. 2 times 2 is usually 4. 2 times -3 is a big old -6. And then we've got 2 times 1 and 2 times -3. There we go. So we'll graph those. All right, so 2, -2 is going to be right there. And 6, -2 will be right there. Way at the bottom here. I think my my picture here that I'm writing on is sized a little too big for the page here. I had some sizing issues. I keep moving things around because my lines to write are below. I guess I could extend the page. Then can I see them? No, I guess I didn't have them on there after all. So I'm going to unextend that page. And the only way I know how to do that is do this. There we go, unextended. I just didn't give myself any lines to write. All right, so let's keep graphing. 4, -6. The words look too small when I extended the page. And 2, -6 is right there. All right, so now let's graph that. Here we can label the coordinates. I didn't really do that in the last one. I really could have, huh? Well, maybe just these ones, A prime, B prime. All right, over here we do have enough space, I believe. So this would be A prime, B prime, C prime, and D prime. All right, so now we want to move it to where A double prime, B double prime, C double prime, D double prime is. All right, well, this is not a reflection, right? They're not mirror images. They're not facing the same way, certainly not. Notice A and A are closer together here, right? But what if we were to turn this, right? What if we were to turn this, right? Could it be a rotation? Well, let's take a look at our points here. All right, so we have A prime, for instance, is at 2, -2. And A double prime is at -2, 2. They're the same, right? But the signs are the opposite. Let's actually write these points down, and then we can see it. You don't have to write this part down unless you have space. So A double prime, that's at 2, -2, and that maps to -2, 2. Same numbers, signs are changed. B is at 6, -2. B double prime is at -6, 2. Matter of fact, if we were to continue, C is at 4, -6. And C double prime is at -4, 6. So notice all the coordinates are the same, but the signs have changed. Right? So what transformation changes the sign? It is a rotation. Right? If you think 90-degree rotation, remember we flip the coordinates and we change, and we so 90 degrees clockwise would flip the coordinates and it would make the second one the negative, and then 180 would flip them back, and both of them would be negative. So this is a 180-degree rotation. I bet you saw that though. So let's write down our transformation. So first we had a dilation, and the scale factor was 2. So that's going to map to 2x and 2y. I'll just write it here because I don't have any lines. And then we have a rotation. Indeed, that starts with r as well. Let's just use a lowercase r for rotation. And xy is going to go to, or map to, -x, -y, right? They're just the opposite. So as a reminder, in case you forget what that is, that's a 180-degree rotation. And it's understood that this has to be around the origin, otherwise we can't use coordinate notation. All right, the last one. Last but not least. All right. So let's look at our figures here. All right, again, lots of horizontal and vertical lines. How about we just take A double prime, D double prime, right? So our scale factor is A double prime, B double prime divided by since I chose AB, I was going to choose AD. That's right. Actually, let's choose AD. It's just kind of easier for me because it's, actually, you know what, let's stick with A double prime, B double prime. It won't be in the way so much because it's off to the side there. And that means we need to go with AB. And that just looks awful. Let me rewrite that just a tad nicer for you. A double prime, B double prime. We really could choose any side we want here, just so long as we match up the corresponding sides. And they just have the same letters. That's really easy to tell. So A double prime, B double prime, that's 3. And AB, well, heck, that's 3. So we have a scale factor of 1. Right? So technically, congruent figures, we have congruent figures here, are similarity transformations. It's just they have a scale factor of 1, which makes them not only similar, but congruent. Right? So similar is the same shape, and congruent is same shape, same size. Right? One figure, there's a sequence of transformations that maps one to the other. Right? So technically, congruent is a type of similar. So we've got our dilation here, scale factor 1. What's the transformation? If you said rotation, you're not quite correct. Right? So if I were to rotate, would turn around, AD would be in front all the time, and it's not. Right? But what if I draw this line in? That might help you see what it is. So if you notice, let's kind of connect them. All right? If we were to connect the corresponding figures, you can see that they are perpendicular to our line of reflection here, right? Which means that's our line of reflection, right? So if you connect corresponding points and they're parallel and perpendicular to some line you can draw, right? That line you can draw has to be your line of reflection. And this is the line y equals -x. Right? So this is a reflection. Right? Sometimes it gets tricky to figure out 180-degree rotation or reflection. But if it was a 180-degree rotation, notice they wouldn't be turned that way. If you look at the 180-degree rotation, notice they're oriented. One's not on its side. If you were to think of like this is the base here, the base is still horizontal over here. It doesn't change to vertical. It would only change to vertical on a 90 or a 270, right? And here, notice what's horizontal is now vertical. So it can't possibly be a 180-degree rotation, right? And it went 2 quadrants, so it can't be a rotation of 90 degrees either. So it's got to be a reflection. And we can see what the line of reflection is. So we're all done here because we have a dilation. XY maps to XY. And then we have a reflection, right? And our reflection, our XY maps to, right? So if we're reflecting over y equals to negative x, even if you forget the rule, if you figure out that much, look at your coordinates. So A, for instance, is at 2, 3. And A double prime is at negative 3, negative 2. So they switched, and they're the opposite. So XY maps to negative x, negative y. So that's a reflection over y equals negative x. And there we go. We're all done. We've done all our similarity transformations. So thanks for watching. And if you have any questions, as always, just ask me in class. And bye for now. And guess what? That is our last dilations near pod. Hey, we did it. All right, bye for now.